All right, we're going to do our first video for technically it's not Algebra 1, it's Intermediate Algebra. Your notes may say Algebra 1 at the top, but we are in Unit 1 of Intermediate Algebra. This unit is all about linear algebra, which means just algebra using straight lines, or graphs of straight lines, or equations of straight lines, or tables of straight lines. Now remember, anytime we have a straight line, our basic form of an equation is called the slope-intercept form. And I want you to write this down somewhere in your notes. The slope-intercept form of an equation is y equals mx plus b. Now, when you have an equation in this form, m is going to be some number, and b is going to be some number. So, for example, here we have one like that, where it's y equals negative 3x plus 4. So negative 3 is our m, and 4 is our b. Okay, another thing I want you to write down is that m means the slope. This is the slope in the equation. B is the y-intercept in the equation. That's why it's called MB, slope-intercept form, right here. Okay, so most of the equations we're working with in this unit should look something like this. If they don't look like this, you can use your skills from last unit, the review unit, to move them around so they do look like this. The most important piece about this is that y is alone. So key terms for this lesson: linear equation, an equation that forms a line when it is graphed. Again, the most common form of this is going to look like this, slope-intercept form. The slope of that equation is just the ratio of the rise, how far one point goes up, to the run, how far it goes over until it meets the next dot when you're graphing it out. So the ratio of the rise to the run of a line, that's what we just call that the slope. It's how fast it's going up or down. So we're going to look at a few examples here. This first asks us to sketch the graph of each line by making a table of values. Okay, so we're going to do this each one kind of twice in a way. Once making the table, and then twice I'm going to show you how you can use the slope to graph it really, really quick. Okay, in each one we're going to use the x values, negative 3 to positive 3. So you can fill that in right away, negative 3 all the way up to positive 3, those are our x values. Now to find our y values, we just plug in these values right here into the equation. So at negative 3, we would plug it in here and say this negative 3 times x, which is negative 3. So negative 3 times negative 3 is positive 9, plus 4, we're at 13. So y would be 13 in that case. Let's say we plugged in negative 2. We'd have negative 3 times negative 2, which would be positive 6, plus 4 would make 10. And so on and so forth. I will let you do the rest, but I'll let you know right now it'll come out to this. This is what the table should look like in the end. As we plot these points out, each point individually, this one will be at negative 3 for our x value. And remember, x is the left and right line. It'll be at positive 13 for the y value. Remember, y is our up and down axis. So we, from the middle here, would go backwards 3, or to negative 3 for our x, and up to positive 13, so a little bit off the chart here. Negative 3 and 13 would be up here. That's where our dot is. Negative 2 and 10, so we go negative 2 up to 10. Negative 1 and 7, so negative 1 up to 7. 0 and 4, right here. 1 and 1, right here. 2 and negative 2. This one we're going in the positive x direction because we're positive, but we're going down beneath this line because our y is negative. Last one we do 3 over 5 down. Now we have all of our points there, all of our dots. We just simply connect them with a line. I'm going to use, mine is going to be more of a ray, I guess. Connect them like that, and now we have graphed our line. Now I'm going to show you a quick way to do that using the equation. You can always use a table. You can also use your equation. Remember, there's m and b for all of these. M is the slope, b is the y-intercept. So this number 4, positive 4, because it's plus here, is our y-intercept. That tells us on this y line, our line will cross at positive 4, which it does. We saw that right here. Okay, So this spot here tells us where to start on this y-axis, up and down. This -3, if it helps, write it as a fraction. You can write any number as a fraction by putting it over 1. So -3 over 1. This -3 is our slope, which remembers the ratio of rise to run. So if this is our rise and this is our run, it's actually, we're not rising, we're falling. We're going down 3, or -3, and run, our over, is 1. So from this one, we would go down 3, 1, 2, 3, and over 1. Notice that's exactly where we landed on before. So our table and our equation match up perfectly, both by plugging in all these numbers, and they match up on this graph with the line. Let's go to the next example. This one, we have y equals 2/3 x minus 2. Again, it's already given in that mx plus b form. Here is our m, the slope. Here's the b, our y-intercept. In this case, our b is considered -2. Even though it's not plus here, we can think of this as 2/3 x plus a -2. So -2 means the same as adding -2, which means I'm going to guess right now that -2 right here is going to be one of the spots on our table. Okay, I can guess that because that is our y-intercept. So I'm going to move our picture out of the way here. All of these are our x values. Remember, -3 up through 3. And we're simply going to plug these numbers into x for the equation. So -3 in for x means we're doing 2/3 times -3. That's going to give us a -6/3, which is actually the same as saying -2. Once this becomes -2, we minus 2 more, and we get a -4. So that means we are going to be, I want to move this right here. We're going to be at the spot -3, -4, right here. That's our first spot. Now, if you were to use a calculator and plug in all of these values for x right here, and then subtract 2 at the end, this is what your table would look like. I'm just going to pull it aside so we can see. Notice how these ones start going in thirds, and that's okay. It'll be kind of hard to plot that, so it would be something like this: -2, and then -3 and a third, and then -1, -2, and 2/3. We're not going to plot all of those. I just want you to plot the whole numbers. So -4, -2, and 0. Those are the main ones. Okay, those are going to happen here, here, like we said it would, 0 and -2, and then 3 over and 0 up. So right here. Now those will all fit on this line. I'm going to use an orange line. It's going to look like this. Okay, so stretch that out, put your arrows at the end. That's the graph of our line. Now again, notice that our table matches with our equation in saying the -2, or -2, that's our y-intercept. Our slope is saying go up 2 and over 3. So that did in fact hit where we wanted it to. This is like our starting point. This tells you where to go. This is your slope. This is your y-intercept. As long as it's in the form y equals mx plus b. This is a special case of y equals mx plus b. In this case, technically, our m is 0. So y equals -3 is the exact thing as saying y equals 0x plus -3. Because 0 times any number is just 0, and then the -3 is still here. So like all of them, our x values are going to be -3 through 3. But no matter what we plug in, -3 times 0 is 0, plus -3 is -3. Let's do -1 times 0 is still 0, plus -3, still -3. Let's try +2 here, times 0, 0, plus -3. They're all still going to be -3, which means if we were to plot this out, be at -3, -3. here, here, here. These dots are all of these points, which means then if we were to graph this line, it makes a perfectly horizontal line. Okay, so anytime you have y equals just a number with no x value, your slope is 0, and it's a horizontal line. Make note of that. If you need to write that down, please write that down. Y equals a number makes a horizontal line. Our next one is going to make another tricky line. In this case, notice there is no y value. Our equation just has x equals 2. So there is no y equals. This is still a straight line, but the only point that we can get is x being 2. There are no other x values. Y can be anything, because y doesn't matter in here. There is no y that's affecting it. So the only thing that has to be true about all of these points is that the x value has to be 2. So I could say, if I wanted to, I could make in the table, I could say, let's say 2, 1, or 2, -5, or 2, 17. I could make anything I want as long as the x value is 2, which means when I plot all these out, they're going to look something like this. And this time, instead of a horizontal line, they will make a vertical line. So if it's x equals a number, it's a vertical line. And we would actually say in that case that the slope is undefined. Slope is undefined when it's vertical, because we're going up an infinite amount of times and going over 0 times. So it's like infinity divided by 0. And you can't divide anything by 0, so it's undefined. Now, if we don't use the graph, if we just know the 2 points, and we want to find the slope in between them. So I'm going to go back to the graph and show you what it would look like if we're going from this point to this point. But they didn't give us a picture, they just gave us the numbers, such as this point is -9, 3. It's -9 over and 3 up. This point up here is -7, 8. We know that because it's -7 over and 8 up. So if they didn't give us the picture, they just gave us these numbers. As in these cases here, this is how you'd figure it out. These 2 points, we'll call them point 1 and point 2, our first and our second. The second point has an x and a y value. So we'll call this x1, or sorry, x2 and y2. We'll call this one at the first point x1 and y1. Now when we find the slope, we're doing the change of the y values over the change in the x values. y2 minus y1 over x2 minus x1. What that means is we're finding the change here, the y change, and we're finding the change here, the x change. We find this y change by subtracting y values. 8 minus 3 is 5. Notice this is 5 spaces up. -7 minus -9 is 2. Notice this is 2 spaces over. Okay, we're doing the same thing, only not looking at it visually, we're just using these numbers. y2 minus y1 over x2 minus x1. That gives you your slope. So let's see an example of this. If we use this as our point 1 and this as our point 2, this is how that slope would look. We would take 8 minus 4 over -6 minus 12. Now that's going to simplify to 4 over -18, and that can reduce to 2 over 9. Because we have a positive here and a negative here, the whole thing is considered a negative number. So we would say our slope is -2/9. This means as we're going from this point to this point, the line that they are on is moving downwards from left to right. We know it's down because it's a negative. Let's say, though, we wanted to switch these. oops, grabbed the wrong thing. We want this to be 0.1 and this to be 0.2. Well, that would look like this then. We would say 12 minus negative 6. That's our x values on bottom, and 4 minus 8 as our y values on top. Remember, y's go on top, 4 and 8. X's, 12 and negative 6, would go on bottom. So 4 minus 8 is negative 4. 12 minus a negative 6, minusing a negative, it's like adding it. So it's a positive 18. This one and this one, the signs are the only thing different. This was positive, now it's negative. This was negative, now it's positive. So it reduces to the exact same thing, negative 2/9. In the end, either way, with this as 1 or 2, or with this one as 0.1 or 0.2, we get the same slope. So, checking this one out then, we'll do the same exact thing, only we'll do it just with one way. We are going to use this is 0.2, this is 0.1. Negative 6 minus 0 over negative 11 minus negative 1. Negative 6 minus 0 is negative 6. Negative 11 minus negative 1. Again, remember that's like adding. Negative 11 plus 1 is negative 10. Negative over negative, those cancel out and become a positive. 6 over 10, we can take 2 out of each of those. We reduce it down to 3/5. So we would say the slope between these 2 points is 3/5. Now we're going to look at the slope of these lines just going from one point to another. Now again, like we said before, these you're simply counting off. So from this point to this point, we're going 1, 2, 3, 4, 5, 6, 7 for our rise. And I'm going to use purple here. 1, 2, 3, 4, 5, 6, 7. Oops, right on it for our run. Now notice this one went down for the rise, so our rise should be negative. It should be a negative 7. This one, we went from left to right, so we moved in the positive direction. It should be a positive 7. Negative 7 over positive 7. Notice if there's one negative and one positive, your answer should stay negative. 7 over 7 is just 1. So our slope in the end is just negative 1, which means it goes down 1 over 1, down 1 over 1, down 1 over 1. So this slope seems to fit with this line. On example 8, we need to find 2 spots where this line crosses. So right here, it crosses the grid. You can see here it's a little bit off, here it's a little bit off. That one's just a little bit above, a little bit below, but it crosses again right here. So these would be our 2 spots that it crosses. Now going from this dot to this dot, what is our rise? Remember, rise is up and down, so we're going up 1, 2, 3, 4, 5. Now again, because we're going upwards, it should be a positive 5. So that would look like this on top. Whoops. 5. And as we move over, it's going over 1, 2, 3, 4, 5, 6, 7. So our run then, it's moving 7 in the positive direction. So our rise over run, 5 over 7, we would say this slope is 5/7. And that'll be it for our lesson on slope.